Okay, well, we'll go to the one you had trouble with because that'll help everybody that had trouble with any of them. We'll just do as many as we can. And we're going to use the help, but we're also going to use the calculator and use TVM solver for as much as we can. Okay, so the woman deposits $10,000 at the end of each year, and I'm going to play like I'm you. That, you know, I don't know how to do the problem other than I've got my notes, and my notes aren't helping much, so I'm going to see if this will help me. So the woman deposits $10,000 at the end of each year for 8 years in an account paying 5% interest compounded annually. Find the final amount she'll have on deposit. Okay. I'm going to ask it to show me an example. The only thing that's different in the example and the problem that I'm doing is that she had $10,000 in the example. This time, and I'm sorry, in the original problem, this time she has $10,750. And the other problem, it was 8 years. Now this time it's 16 years, and it pays 9% interest, not 5% interest. So we'll do this part. To calculate the amount she has on deposit after 16 years, determine which formula is needed. Okay, after 16 years tells you that's in the future. So that means that's actually her future value. Her contribution is what's called an ordinary annuity. And one thing you need to remember, write this down somewhere, is that in an ordinary annuity, your payment plan has your payments at the end of each period. I'm sorry, at the beginning of each period. Ordinary means beginning. Annuity due means end, because your payment's due at the end of the month, if that helps you remember. So this is the correct formula. Now they call it S. That's the future value. And the reason they call it S is because it's the sum of all your payments plus the interest on all of your payments. Okay? In the other problems, they call it A. A and S are both used for future value. R is the payment period, and it's made at the end of each period. And she's making her payment at the end of each year. And I is the interest rate per period, N is the number of periods. So the interest rate per period is 9%. Over a period of once a year is going to be 9%. They only compound annually. And then her number of periods is her number of payments, actually, and that's 16 payments. So what we do is we go in, and first we're going to do the calculator formula. Let me actually get a piece of paper to switch over to write down what everything is in the formula, and then we'll step through how to do it on the calculator. So the formula is S, which is the future value, is equal to her payment amount, which in the example is $10,750, times 1 plus the decimal value of the interest rate, which is 0.09, raised to the nth power, n being how many times did they compound it? Well, they compounded it for 16 years, once a year. And then once you get that amount, we're going to subtract 1 from it. And then we're going to divide the whole thing by that interest rate, which is 0.09.
Which formula are you using for
This one right here.
Is the power a negative? I can't really see that.
The power is not negative on this one.
Oh,
The power is not negative on this one. That's why I wanted to get another marker. I knew this one was starting to dry up. That's the only one I got. Can you see that any better? I think it may be the light. Let me see if I can do this. Does that help? At all?
Yeah, I can see it a little bit better now. I can actually see it, yeah.
Okay. So none of that's negative. What it is this is, just to make sure you're identifying everything, this is R. This is I, which is equal to the rate per year divided by the number of times per year that you compound it. And this is that same I. And the reason it stayed 0.09 is because you're only compounding once a year. So that's 0.09 over 1 year. And then 16 is N. So what these all stand for, R is the payment. I, in this problem, is the annual interest, is the interest rate. Annual interest rate. And we actually have to divide it by the number of periods or compoundings. So that's the number of years times the times compounded per year. So we'll get the calculator and come over here, and I'm going to show you how to, do not try to put that big whole mess in your calculator all at one time. Okay, don't do that. That's where the mistakes come in. What you want to do is you want to go inside your parentheses and do this as step 1. 1 plus 0.09. And while I know that you're not likely to mess that up, I would still say 1 plus 0.09. Enter. Because sometimes I don't even trust myself to add 1 to something. And then it says, now raise that to the 16th power. So we're going to raise it to the 16th power. And then it says subtract 1 from it. So we're going to subtract 1 from that. And then it says, and divide that by the interest rate. So we're going to divide by 0.09. So everything that is in that square bracket has a value of 33.003398. That's what you've done so far, is you've done everything in square brackets. Now the only thing you have left to do is to multiply that amount times the $10,750. And that gives you her future value. So with that information, did you not get the same thing I did?
Yeah.
Okay. So the future value of her investment is $354,000. $354,786.54. So we're gonna press continue and make sure that that's what they said it was. And that's exactly what they got. Okay? Now, here's the part that I want you to do, even though I know that you've not been doing this way. Go ahead and go to your finance formulas, go to your solver. And I'm going to add some notes here. For the solver. So you want to write these down. Okay, N is the number of payments. And the way that you find it is number of years is the number of years times the number of compounds per year, the number of times that it's compounded. If it's compounded annually, that's one payment a year, times the number of years. If it's compounded semi-annually, that's 2 payments a year, times the number of years. If it's compounded quarterly, that's 4 payments a year, times the number of years. If it's compounded daily, then that's 360 times the number of years. If it says it's compounded continuously, that's a different formula, and this doesn't do that. But if you do daily compounding, you'll get darn close to the answer. It'll be within a penny or two. Okay? The interest rate, I, has to be as a percent, and it is the annual interest rate. It's not broken down. You don't divide by anything. You put in the whole interest rate, and notice that it has to be as a percentage, not a decimal. It has to be percent. PV stands for exactly what it sounds like, present value. It's what you have today. What you start with. Payment is what it sounds like it is. It's the amount of each payment. Future value is the amount you're going to have in the future. All payments plus all the interest. It's all the money you're going to have at the end. Okay? When you're done. These two things have to be equal. And what it is the number of payments or compoundings. Per year. Once again, if that was annual, both of those are going to be 1. If it's semi-annual, both of those are going to be 2. If it's quarterly, both of those are going to be 4. If it's daily, both of those are going to be 360. If it's monthly, both of those are going to be 12. But they have to be the same thing. And on deciding between this is called an annuity due and an ordinary annuity. And an ordinary annuity, the payments are made at the end. If it says the word annuity due, you change that to beginning. If it's a mortgage that you're calculating or a car payment, you know that you make your mortgage and your car payments at the end of the month. You don't make it at the beginning of the month. The beginning of the actual mortgage, the beginning of actually getting the car is the day that you buy it. You might make a down payment that day, but your first car payment doesn't come due until the end of that month. So does that make sense? Okay. So then we're going to use that same information that we just used in this problem above in the solver. So in our problem, the interest rate is 9%. So I'm going to change that to 9. The number of times it's going to be compounded is for 16 years, once a year. The present value, I have no clue. It doesn't even ask me what her present value is. So I don't care. Not only do I not know, I don't care. It's asking me what is her future value going to be. It gives me her payment amount. Her payments are $10,750. Her future value is what I'm looking for. And she makes payments once a year. And notice that as soon as I move it down to compoundings per year, it changes it to the same number. And she makes her payments, it says, at the end of the year. So once you've set your screen up, what we want to know is what was her future value? What is the sum of all of her payments plus all of her interest? So we put the cursor at future value, and because down here above the enter key it says solve, and solve is in green, then I need to press the green button. If it's on your calculator and solve is in blue, then you go press the blue button. So the button tells you which one you need to have, and it gives me the same answer, $354,000 with $786 and 54 cents attached. Okay? Now that will help you, because then if you've made some little tiny mistake in the arithmetic over here, it's going to tell you, because that little tiny mistake in arithmetic over here done by hand, step by step, translates to a big difference when you get to the end because of those big huge powers. Okay? So now, just for practice, we're going to close the example because we know how to do that part now, and we're going to do the problem that's here. So in this problem, she's going to deposit $10,000. We don't care about the present value at this moment. She's going to go for 8 years at 5% interest compounded annually, so 8 years times once a year. Interest rate is 5%. Compounded once a year, payments once a year, payments are at the end. Future value is what we want to know. So you put your cursor on what you want to know, and then alpha, enter, and it says the amount that she'll have on deposit is $95,491.09. Now, unfortunately, it will not let me go to part B at this point, I don't think, because I don't have a check answer button. Unless it's hiding it from me. No. Let me go back. So that was what, problem 12?
What did you say you got for that?
The one I did, $95,491.09. Is that not what you got? Let's try this one. She deposits $10,000 at the end of each year for 8 years, 5%. No, this is the same problem.
Mine's a little different than yours, but it's not thinking
Okay, let me see what you put in and see what your problem says. Yeah, and it will count it wrong. It will count it wrong.
This one, I did this problem, and I got the first part correct. And, I plugged in the exact same thing, obviously, a problem. I just like, got the answer, I'll do that. I'll hit graph, and trace it. 8.7.
This means that her ninth payment,
Yes. It says there.
okay, did you take into account, go ahead and tell it,
$8.
just close it, don't do anything else. Is that the same problem you started with?
Yeah, that's the.
Okay, now, come back here, go to your solver. I'm gonna show you where I think the mistake might be. Or go to your equation. Okay? She bought $18,000 and $7,300, and she paid $17,000 down.
Yeah. Yeah, that's subtract that.
Okay, are you sure you did that right?
Yes, well, I got the payment correctly.
Okay.
So when the y equals, so it's just a formula, it's just that number and then.
Compounded semi-annually.
Yeah, like this is the equation, like I just don't know how I
Okay.
get 3.
Okay.
Like, I
Okay,
plugged it
here's
out of
why.
the equation.
Here's why you're not thinking of something.
Is it like, I don't know, or something?
No. Remember that this N is the number of payments that she's made, okay? So,
Hold on, I think I got it. Well,
at this point, the first year, she makes payments 1 and 2. The second year, she makes payments 2 and 3. Third year, she makes payments 3 and 4. That's actually the way they ask the question, though.
would I like subtract a certain number from that?
made, when she makes the 8th payment, her balance is $8,000. So when she makes the 9th payment, it drops down below $8,000.
I really struggle with five.
I don't understand why it's telling you, okay, no, I don't want you to solve that. I want you to just show me how to do this. Okay, that's fine.
See, I got that, that's the
Uh-huh.
2814, I plugged that in back to the 6.
Number of payments, look at the first one on the graph with accordance an integer and the second one is less than 9,000, which may be, and we did that. After 8 payments, the remaining balance falls below $9,000.
That's the next.
There's a total of 12 payments. Yes, you subtract. We got 9 from, there would have been 12 payments. So yes, I understand now because I wasn't reading the question
Yeah,
either.
subtract
How many payments
12 by 9.
left, not how many payments had she made, how many were left to make.
I have a question. There's a problem right here.
Mhm.
It's,
That's the present value of an ordinary annuity.
right, well, when I type in this, when I type this, I was just about it, but when I type in my interest in your future value, but that didn't make sense.
16,000 is the future value. You got it in the right place.
Okay.
She wants to deposit the end of each quarter, which is 4. And the account paying 5.1% interest, so that's 5.1. 5 years times 4 times a year is 20.
That's what I got for that. So this is, okay, but why is this? Why is this? Is she paying
It's just she wants, okay, when is she buying the car?
with the 25? Okay.
She's not buying it today. She didn't buy it yet. She didn't buy it yet. That's the thing. What she needs today, if she had it, what she needs today is $16,000. But in the future, to buy that car for $16,000 today, she doesn't have it. So that's the future value. That's how much she wants to have. She wants to save up and pay cash for the car. She does not want to make car payments. Okay?
Makes sense now.
Okay. I will see all of you on Tuesday after Easter. Please be sure to get your test done before then and bring it to me on paper.